Okay, everyone, welcome. In this video, we're going to go over testing using contingency tables. So this is a new topic, but hypothesis testing kind of works the same way. So we have seen hypothesis testing before. Now let's see what the contingency tables are and how we do the hypothesis testing with those tables. A contingency table, it's a two-way table. We did see this in the beginning of the semester when we were doing probability. We have seen this with uh, probability probability applications. So here, two-way tables, that means we have the rows and we have the columns. So that's how it works. Now I will go over the example of this example, see how this works. But usually when you're given a table like that, this table is called a contingency table. So it's is a multinomial experiment or process. With these tables, we always have two types of tests. So one is test for independence, and the other one is test for homogeneity of proportions. You have to be careful which test the problem is asking because they work exactly the same way, although the claims are not written the same way, but the procedure is the same. What is the procedure? The first is state the hypothesis or identify the claim. Basically, you write the claim, and I will go over an example. Find the critical values. The multinomial experiments, they are always chi-squared right-tail test. So again, chi-squared right-tail test. I kind of draw it here fast. It's not, it's skewed right and it's not symmetric. So we'll go over finding the critical values. Now, the test statistics you use that this is not x, this is chi-squared equals to sum of O minus E squared divided by E. O are the observed values, the values that are given in the table already. E are expected values, we need to calculate them. So the formula is row sum times column sum divided by the grand total. I will go over that in the example. Since we're dealing with chi-square distribution, we have to know the degrees of freedom, which is r minus 1 times c minus 1. R is number of rows and C is number of columns. Then, of course, conclusion, reject HO or fail to reject HO, depending where the test statistics fall. And after that, we can make the final conclusion. I have an example for both test for independence and test for homogeneity of proportions. So let's do the first example, says test for independence. A researcher wishes to determine whether there is a relationship between the gender of an individual and the amount of alcohol consumed. So basically, we want to know if there is a relationship, or just let's put it this way, if females drink more or males drink more. That's interesting to know. A sample of 68 people is selected and the following data is contained. So the data is in the table. At alpha equals to 0.1, can the researcher conclude that that alcohol is consumption, that alcohol consumption, let me take this out. Alcohol consumption is related to gender. So now when you're given the table, you're only given these red values. These are the observed values. So the total sometimes it's given, sometimes it's not. If it's not given, you have to find the total. So it's 9, 10 plus 9 plus 8 is 27, and so on. 13 plus 16 plus 12 is 41, and vertically 10 plus 13 is 23, and you can get those two. And the grand total here is 68. If you add these numbers, you get 68, and if you add those numbers, you should get 68. That's a way to check yourself. Now, how do you write the claim for this? No numbers involved for this type of problems. HO, the amount of alcohol that a person consumes is independent of the individual gender. H1 or HA, the amount of alcohol that a person consumes is dependent of the individual gender. Remember, HO is always independent and H1 is always dependent. So any type of problems you have, if you're checking for independence, for HO you write independent, and for H1 you write dependent. Let's find the critical values. The critical values, so first the degrees of freedom is R minus 1. We have only 2 rows. Do not count the total, which is 2. And times C minus 1, we have only 3 columns. So is 3 minus 1, and that's going to give you 2. 1 times 2 is 2. Now, how do you find that? You should go to your chi-square table, and then degrees of freedom 2, and we know alpha was 0.1, and I can probably share that with you. Just have to find the table, and so there we go. This is the chi-square distribution. So one more time, we set 0.01 and degrees of freedom 2. So if you come here, you get that number, which is 4.605. So let's go back to our problem. So there we go, 4.605, that's the critical value, and it's a right-tailed chi-square test. We already said that. Then you have to find the test statistic. The test statistics, chi-squared equals to sum of O minus C squared, and that's divided by E. And I put the note here for you. Observed values are whatever is seen on the table, and E are the expected value which we calculate. So the first, you have to go to each box. It says O minus E squared divided by E. O is the observed value minus E, which is, we calculated that. So we said E is row sum, 27, times the column sum, 23, divided by the grand total for each single box here. So you find that, and 10 minus 9.13 squared divided by 9.13 is for the first one. 9 minus 9.93 squared divided by 9.93 is for the second one. 8 minus 7.94 squared divided by 7.94 is the third one, and you have to do for each one of them and add them. So I put it here. I put for 3 of them, and I put etc. because it continues. And if you add all those, calculate all those, you get 0.28. So 0.28, let's go see where is 0.28. 0.28 is here is in the non-shaded area. So again, first conclusion we already know. Non-shaded area is failed to reject HO. Failed to reject HO. That means we are accepting this claim and rejecting that one. So we are accepting that they are independent. So, and I put here, failed to reject HO, so the amount of alcohol that a person consumes is independent of the genre. Now let me show you how you can do that with a calculator. So before I share the calculator, I want you to know we have two rows, 1, 2, and 3 columns. So 1, 2, 3. And the red ones are the observed values. That's what's going to be given to you in the problem. So let's go to the calculator, which can do this very fast. Now, the first thing you want to do is put this data in a matrix, which is an array of tables. So the calculator has that. You have to do second function. Matrix is right there on top of x to the power of -1. So click on that and go to edit and just pick the first one. You have to put the size of the matrix, which is the size of our table. The first number is number of rows. So we said we had 2 rows. The second number is number of columns. So we said we had 3 columns, and you enter that. And you put the numbers one by one. First number is 10. Then we have 9. Then we have 8. Then we have 13. Then we have 16. And finally 12. And you enter that. Once you complete the matrix, then you go to stat again and tests again. Scroll down and you're going to see chi-square test. You have chi-square GOF test. This is goodness of fit. I'll talk about this in the next video, but this is just chi-square test. So you enter that, and all you have to do is to push on calculate, enter calculate, and guess what? The test statistics is given 0.280, 0.28. With your calculator, you don't need to calculate the expected values because calculator does that automatically and gives you the answer. And of course, P here is the p-value. You can use the p-value method to make the same conclusion which we just did. Okay, let me stop sharing that and share the next example, which I only use the calculator, but let's go over this. Now, the second type of example or the test you can have is test for homogeneity of proportions. Let's go over this problem. A researcher selected 100 passengers from each 3 airlines and asked them if the airline has lost their luggage on their last flight. The data are shown in the table below. At 0.05 level of significance, or alpha equals to 0.05, test the claim that the proportions of passengers from each airline who lost their luggage on the flight is, or on the last flight is the same for each airline. So here is the table. They lost, yes, no, and we have the airlines 1, 2, and 3. How do you write the claim for this? You just say P1, the proportion of the flight 1 equals to the proportion of the flight 2 equals to proportion of the flight 3. For H1, you write that at least one is different. At least one of these top proportions is different. So that's always how you state the claim for this type of problem. Critical values, degrees of freedom, number of rows, we have 2 rows, times number of columns, 1, 2, 3, we have 3 columns. So 2 minus 1 times 3 minus 1, and again 2. You go to chi-square table, and I think by now you know that. So here you look for alpha equals to 0.05 and degrees of freedom 2, and if you do that, you should see 5.991. Test statistics, let's use our calculator for test statistics in this case. And remember, is 2.765. When you go to your calculator, you are going to enter the observed values on the table, and let's go ahead and do that. So one more time, you go to second function matrix, then scroll to edit, enter. This table is also 2 by 3, so we don't have to change anything. We just have to change the numbers. So the first number is 10, and don't forget to enter. Then you have 7, then you have 4, then we have 90, then we have 93, then we have 96. So you enter that. Once all the values are entered, go to stat, test, scroll down until you find chi-square test. And that's the one, C. You enter that, don't do anything else, just calculate. 2.7649, which is 2.765, same way. And of course, P, we know it's the P value. Let me exit here and let's make the conclusion. So we found our critical value to be 5.991 and chi-square is 2.765. Non-shaded region, so right away you can say fail to reject HO. Fail to reject HO, that means accept HO and reject H1. We are accepting that all 3 proportions are the same. So for the final conclusion, you can just say fail to reject HO, conclusion P1 equals to P2 equals to P3, or you can say the proportions are the same. Here I did put the summary for the calculator. So one more time, second function matrix, then so you have, when you go to matrix, you have names, math, and edit. So you highlight edit. Number of rows and number of columns, first rows, then columns, don't forget. Then you go to stat, you pick test, and you go to see chi-square test, and you just calculate. And the calculator is going to calculate the test statistics p-value, and it will give you the degrees of freedom. I think that's it for this lecture now. I think you are ready for the homework for this type of problems, and they're basically all the same. They look all the same. just know the formula, it's very good, and know how to use your calculator also. Hope you all have a good one, and I'll see you in the next lecture. Bye bye.